On June 19, 1957, the U.S. military conducted the first live fire test of a nuclear air-to-air missile over a remote test range in Nevada. A Northrop F-89 Scorpion interceptor from the Air Defense Command launched the Douglas MB-1 Genie, which successfully detonated seconds later, producing a powerful nuclear explosion and shockwave. While standard air-to-air missiles were already in use at the time, this specific test marked a major shift in military technology. By successfully deploying a nuclear payload from a fighter aircraft, the event initiated a new era of nuclear-armed combat aviation. To understand how we got there, we have to look back. Toward the end of World War II, Northrop engineers already had solid experience with advanced military aviation technology, specifically jet engines and radar. They were the ones who rolled out the very first purpose-built radar interceptor, the P-61 Black Widow. Designed for the Army Air Forces, they had also built their first experimental jet, which featured a futuristic flying wing design. So it made perfect sense for Northrop to throw their hat in the ring. This happened when the military issued a requirement for a brand new radar-equipped interceptor. The Army Air Forces officially issued the requirements for the new all-weather fighter on August 28, 1945. For the era, the performance specs were staggering. Top speed at sea level needed to hit 550 miles an hour. Up at an altitude of 35,100 feet, the aircraft had to reach 525 miles an hour. It was expected to climb to that altitude in just 12 minutes, and the total range was supposed to be around 600 miles. On top of the standard machine guns and cannons, the plan was to arm this new interceptor with air-to-air missiles. Interestingly, the top brass did not even specify that the aircraft had to be a jet, but to the leading engineers, it was obvious. The future was all jets. That is exactly why all the major heavyweights competing in this contest ditched outdated piston engines and went all in on turbojets. These competitors included Bell, Consolidated, Curtiss, Douglas, Goodyear, and Northrop. Out of the gate, Curtiss had a massive head start. They already had a working concept for a heavy fighter that had been in development since the war. Once the war ended and the military needs shifted, their engineers quickly adapted it to meet the new interceptor specs. Their updated design was ready to go by November 1945. Meanwhile, the competitors were still at the drawing board. Over at Northrop, though, they developed 4 completely different concepts simultaneously. In March 1946, a military review board selected just one of them to actually be built. Interestingly, one of the rejected designs was a flying wing. This was largely because an earlier prototype of that shape had suffered a fatal crash in the fall of 1945. The interceptor approved by the military was officially designated the Scorpion. The Army Air Forces ordered 2 test prototypes of the new aircraft. A production contract was signed in September 1947. However, while the paperwork was still being finalized, engineers introduced so many technical changes and design upgrades that the overall cost skyrocketed. The following year, in 1948, the newly independent United States Air Force revamped its aircraft designation system. The old P for pursuit was dropped, and all fighters and interceptors were grouped under the new F prefix. That is how the ambitious project from Northrop officially received its legendary designation, the F-89 Scorpion. The new interceptor was purpose-built to hunt Soviet bombers. With the oceans acting as massive natural buffers, the most likely attack route for Soviet aircraft heading toward the United States was straight over the Arctic and Alaska. Because of this, the primary deployment zone for the Scorpion was obvious from the start. It was the freezing, unforgiving north. An Arctic interceptor needed docile handling characteristics and bulletproof reliability. This dictated its aerodynamic layout. Northrop went with a straight wing to guarantee stable low-speed handling and safe landing speeds in severe weather and at night. The heart of the aircraft was a pair of Allison J-35 GE-3 turbojets. Each produced around 4,000 pounds of thrust. They were built under license from General Electric. The engines were mounted low in the fuselage, side by side. The air intakes were positioned extremely low, almost hugging the tarmac. Meanwhile, the exhaust nozzles exited just below the wing roots. To prevent the scorching exhaust blast from damaging the lower tail section, the fuselage was reinforced with specialized heat-resistant steel plating. This engine placement had a major aerodynamic advantage. It completely eliminated the need for long, inefficient intake ducts. This freed up the entire nose section for a massive radar system. It also made ground servicing much easier for the maintenance crews, but it came with a serious drawback. The low-slung intakes created a constant FOD hazard, easily sucking up debris from the runway. The airframe was an incredibly rugged, all-metal design. The main landing gear retracted inward into the wings. Interestingly, the tire pressure was incredibly high, around 200 psi. The twin-wheel nose gear, positioned just behind the intakes, retracted backward under the cockpit. Fuel was carried in fuselage tanks and housed inside the straight wings. These wings were built around a heavy-duty spar structure. The designers also planned to mount fixed fuel tanks on the wingtips. However, the first prototype flew without them. For flight controls, Northrop engineers decided to use a cutting-edge system for the era, decelerons. These were split control surfaces that functioned as both conventional ailerons and speed brakes. This technology had already been successfully tested on the experimental XP-79B flying wing. The designers believed this setup would make the bulky interceptor much more maneuverable during an attack run. It would allow the pilot to easily track a target on radar, line up the shot, and fire. However, the prototype made its maiden flight with standard, conventional ailerons. There were plans to swap in the new decelerons later in the test program. The tail section looked fairly conventional. However, the horizontal stabilizer was mounted about halfway up the vertical tail. This mid-tail configuration was specifically designed to keep the control surfaces clear of the hot exhaust blast from the turbojets. The crew consisted of a pilot and a radar observer sitting in tandem. They sat in a fully pressurized cockpit under a single canopy, complete with ejection seats. Even though rockets were supposed to be the primary weapons for this interceptor, the military insisted on adding guns as well. Initially, they wanted a powered nose turret housing 4 20mm cannons. However, early production models received even more firepower. They had 6 20mm cannons fixed along the forward fuselage. The first prototype, designated the XF-89, was temporarily fitted with Allison J-35A9 engines. Pushed to the max, they could produce 4,000 pounds of thrust. However, they could not sustain that output for long. Their continuous thrust rating dropped to just 3,500 pounds. It was clear to the engineers right from the development phase that the aircraft was going to be severely underpowered. After all, calculations showed the takeoff weight of the interceptor would exceed 35,000 pounds. Once the first XF-89 prototype was assembled, it was carefully transported to Muroc Army Airfield. This site is known worldwide today as Edwards Air Force Base. It was there, on August 16, 1948, that test pilot Fred Brecher took the experimental Scorpion into the air for the very first time. The airframe was painted gloss black. By October, an extensive fly-off was already underway at the base. 3 competitors faced off for the production contract. These were the Northrop XF-89, the Curtiss XF-87, and the Douglas XF-3D1. It is worth noting that the Douglas model was originally designed from the ground up. It was meant as an all-weather carrier-based interceptor for the Navy, but the manufacturer hedged their bets. They pitched the aircraft to the Air Force as well. Naturally, this move infuriated the Navy brass. This was because their budget was funding the development of the aircraft. Air Force crews participated in the trials. 3 pilots, radar observers, and maintainers were assigned to each aircraft. Their main objective was to select the best overall interceptor. Both the pilots and the ground crews unanimously awarded first place to the Douglas XF-3D1. Second place went to the Curtiss XF-87. Meanwhile, the now famous Scorpion came in dead last. However, a special board of 11 high-ranking Air Force officials reviewed the flight data and test results and reached a different conclusion. They ultimately favored the Northrop design and recommended it for production. At the time, Curtiss already held an initial contract to build the first 88 F-87A Blackhawks. But in November 1948, that deal was abruptly canceled after the Scorpion got the green light. Douglas was not left empty-handed either. Their design entered service with the Navy and Marine Corps. It went into production as the F-3D1 Sky Knight. The XF-89 prototype began its initial flight testing without wingtip fuel tanks. In this clean configuration, its wingspan was 52 feet. It had a total wing area of 606 square feet. Down on the deck, the experimental Scorpion could hit 602 miles per hour. Up at an altitude of 35,000 feet, its true airspeed dropped to 536 miles per hour. To reach that operating altitude, the aircraft took just over 20 minutes. Once the massive wingtip tanks were installed, holding 1,200 gallons of fuel, the flight dynamics of the aircraft noticeably shifted. The rate of climb took a significant hit. The jet now needed almost 22 minutes to reach 26,500 feet. There was a major upside, however. Thanks to the extra gas, its maximum range increased to 822 miles. After completing 32 test flights at Muroc Air Force Base, the first F-89 underwent several upgrades in late 1948. Instead of conventional ailerons, it was finally fitted with the intended decelelerons. The updated aircraft returned to the skies on February 1, 1949. Flight testing proceeded smoothly until an emergency occurred. This happened on June 27th during its 64th flight. During a high-speed, low-altitude pass, the aircraft suddenly experienced severe control issues. Fortunately, the test pilot managed to wrestle the aircraft back under control. He then made an emergency landing. During the hard touchdown, the landing gear collapsed and the fuselage sustained damage. However, this accident did not derail the Scorpion program. Back in May, Northrop had already secured a contract. They were to build a second, improved pre-production prototype, the YF-89A, along with a batch of 48 production F-89A fighters. The first XF-89 was repaired and returned to the air by mid-October 1949. However, its story ended tragically on February 22, 1950. The aircraft crashed during its 102nd flight. The cause was a structural failure of the tail section caused by severe flutter. These dangerous vibrations were triggered by the aerodynamic forces and powerful exhaust from its own jet engines. Engineers immediately began redesigning the tail assembly. To resolve the issue, they added external mass balances to the pre-production YF-89A and all subsequent production Scorpions. Naturally, the production aircraft featured other major differences from the early prototypes. Starting with the YF-89A, the interceptors were equipped with more powerful, afterburning Allison J-35 A-21 turbojets. Each produced an impressive 5,000 pounds of thrust. Additionally, engineers lengthened the nose section. This brought the overall length of the aircraft to 53.5 feet. However, they decided to slightly downsize the bulky wingtip fuel tanks. This reduced their capacity to 300 gallons each. The Air Force wanted the aircraft to be a versatile platform. They intended to use it not just as an interceptor for hunting airborne targets, but also in a ground attack role. For this reason, the production F-89A was equipped with a heavy-hitting arsenal of 6 20mm M24 cannons, as well as underwing pylons. These pylons could carry heavy aerial bombs weighing up to 1,600 pounds each. Furthermore, rocket rails were installed under the wings. This allowed the fighter to carry 16 5-inch HVAR unguided rockets. The first full production F-89A took to the skies on September 28, 1950. However, Air Force leadership was in no rush to officially adopt it into service. The brass was still concerned following the fatal crash of the first prototype. To restore confidence, Northrop had to subject the production models to an extensive and rigorous testing program. By that time, the initial order had been slashed from 48 to just 18 aircraft. 6 of these airframes were put through extreme testing by military specialists. Some aircraft were specifically tested for vibration and flutter. 3 other Scorpions were evaluated for maintainability. Meanwhile, pilots used the remaining 9 to develop combat tactics for the new interceptor. Throughout these grueling tests, engineers continuously refined the aircraft. They made several crucial design changes. This led to the development of the upgraded F-89B. This variant would become the first truly mass-produced version for the Air Force. The B-model Scorpion took to the skies for the first time on May 2, 1951. Its primary difference from the earlier F-89A was the addition of a state-of-the-art Lear F-5 autopilot. It also featured heavily upgraded avionics and internal systems. They did not swap out the radar, however. The aircraft retained the familiar and proven ANAPG-33 radar system. Initially, the Air Force ordered 64 F-89B fighters. An order for another 100 of these aircraft soon followed. However, almost all the jets in this second batch rolled off the assembly line as the updated F-89C variant. Designers were constantly improving the aircraft. For instance, the early F-89A and F-89B eliminated dangerous in-flight tail flutter using heavy external mass balances. The F-89C moved these internally. This kept the aerodynamics of the airframe clean. Additionally, unlike its predecessors, the F-89C gave the pilot the ability to jettison the wingtip fuel tanks in an emergency. This was a critical feature for combat maneuvering. Engineers also made major upgrades to the fuel system and cockpit environmental controls. In June 1951, the first F-89B Scorpions entered service with Air Defense Command units at Hamilton Air Force Base. It is worth noting that in the U.S., air defense was not a separate military branch. Instead, it operated directly under the Air Force. By early 1952, American pilots began transitioning en masse to the new, more capable F-89C. Over time, the F-89C received a significant power upgrade. They were fitted with improved J-35A-21A turbojet engines. These engines put out around 5,100 pounds of dry thrust and 6,800 pounds in afterburner. The evolution did not stop there. Even more powerful J-35A-33 engines were eventually integrated. These delivered 5,400 pounds of dry thrust and a full 7,400 pounds in afterburner. These new power plants featured some critical upgrades. They included an anti-icing system for high altitudes, as well as retractable intake screens. These screens closed off the engine inlets during taxiing. This helped to prevent rocks or debris from being sucked inside. These same powerful engines were installed on the next, much more formidable variant of the Scorpion. This version was designated the F-89D. This aircraft completely changed its approach to armament. Following a concept envisioned by military strategists at the end of World War II, rockets became the primary weapons of the interceptor. They completely replaced traditional cannons. Now, the jet carried a staggering 104 Mighty Mouse 2 and 3/4-inch folding fin aerial rockets. They were housed in massive wingtip pods. These pods held exactly 52 rockets on each side. Interestingly, on earlier versions of the jet, the entire space inside these wingtip pods was dedicated strictly to jet fuel. Now, rocket launch tubes were mounted in the forward sections. Because of this, the fuel capacity in each pod was reduced to 308 gallons. The jet fuel was securely separated from the rocket bay by a firewall, while the design of the pod safely vented the hot rocket exhaust outward. Removing the cannons from the nose of the aircraft freed up space. This allowed the installation of an additional 262-gallon fuel tank. Additionally, two 300-gallon external drop tanks could be mounted on underwing pylons. When fully fueled, the total capacity of the aircraft reached an impressive 2,834 gallons. The order for the first 193 F-89D aircraft came through in April 1951. But with the Korean War underway, the need for these interceptors was urgently reassessed. The order skyrocketed to 862 jets. As a result, the F-89D became the most produced variant in the history of the Scorpion. Alongside its heavy rocket armament, the aircraft was fitted with an advanced radar. It also had a brand new fire control computer linked directly to the autopilot. The weapon system was incredibly flexible. It allowed the pilot to fire rockets individually or in massive salvos. During a full salvo, all 104 Mighty Mouse rockets would leave the pods in under half a second. This allowed all rockets to be fired simultaneously toward the target. The pilot could also split up this payload. They could fire two ripples of 62 and 42 rockets. Alternatively, they could let off three shorter bursts of 42, 32, and 30 rockets. By November 1952, the United States Air Force finally received the first 5 production F-89D interceptors. But earlier that year, in September, something unexpected happened. Air Force Command abruptly grounded all Scorpions. This decision came as a total shock. Initially, the performance of the aircraft in operational units had not raised any red flags. The interceptor had proven incredibly stable in the air. It handled beautifully in all weather conditions. Also, pilots had not reported any major issues flying it. The trouble started on February 25, 1952, when the first fatal crash of an F-89C occurred. 5 more identical crashes subsequently occurred. The final one happened on September 15th of that same year. While investigators scrambled to figure out what was causing these fatal accidents, leadership ordered the immediate grounding of all Scorpions. This included the brand new F-89D. When the investigation board concluded its work, the findings revealed a critical structural flaw to the Northrop engineering team. It turned out that during hard maneuvering and high G rolls, the wing-to-fuselage attachment points just could not take the stress. They were failing in mid-flight. Engineers had to rush to redesign the structural weak points. They also had to modify the airframes of the jets that had already rolled off the line. To fix this fatal flaw, Scorpions were sent back to the Los Angeles factory en masse. By January 1954, 194 early model aircraft had gone through the necessary structural reinforcements. Because of this massive engineering crisis, fully integrating these interceptors into the air defense network was set back by nearly an entire year. Naturally, the wings on the newer F-89D variant had to be structurally reinforced as well. When the problem was finally pinpointed, about 100 of these jets were sitting right on the assembly line. They needed immediate modification. Because of this, deliveries of the updated version to the Air Force did not resume until January 1954. That is when the rocket-armed Scorpions finally entered service with the 18th Fighter Interceptor Squadron up in Minneapolis. But the teething problems did not stop there. It turned out that the early J-35 engines were incredibly unreliable. Once you climb past 29,500 feet, they just would not produce the required thrust. The Air Force had to quickly find a replacement. The aircraft were soon refitted with the much more capable J-35A-47 engines. These new power plants were eventually retrofitted on all operational early production models. They were also installed on the F-89Ds that had originally rolled off the line with the older engines. But on top of its engine issues, the F-89D ran into serious problems with its weapon system. The issue was that moisture kept finding its way into the open rocket tubes. This caused heavy corrosion. That eventually led to several dangerous accidents and even fires during live fire training. Northrop engineers had to go back to the drawing board and rethink the design. They came up with a pretty ingenious fix. They installed a frangible fairing on the nose of the rocket pods. It reliably protected the weapons from water during flight. The moment they fired, the rockets would just punch right through it. Even though new teething problems kept cropping up in service, it did not slow down the assembly line one bit. This was because the demand from the Air Force for interceptors was massive. Throughout 1954 and 1955, production at Northrop kicked into high gear and hit its absolute peak. Running at full capacity, they were rolling out 25 aircraft a month. Soon came the next step in the evolution of the fighter. This was the F-89H variant. Its main feature was the brand new GAR-1 Falcon, air-to-air guided missile. The aircraft could now carry 6 of these missiles. They were mounted on special hardpoints around the perimeter of the wingtip pods, right alongside the unguided Mighty Mouse rockets. However, this meant they had to slightly reduce the number of standard rockets inside each pod. The number went down to 21 apiece. On January 27, 1955, the first successful test launch of the GAR-1 missile took place. An F-89D, specially modified for these tests, fired the weapon. It scored a direct hit, destroying a QB-17 drone. To make sure these advanced missiles hit their mark, the aircraft was fitted with the much more sophisticated E-9 fire control system. This was a huge step up from the older E-6 system used on earlier variants. The new electronics gave the radar observer a massive advantage in targeting. This significantly increased the probability of a successful intercept. By September 1955, production F-89Hs started entering service. They joined the 445th Fighter Interceptor Squadron based at Wurtsmith Air Force Base. The aircrews immediately got to work mastering their new hardware. By March of the following year, this squadron made history. It became the very first Air Force unit to fully transition and qualify on these heavily armed Scorpions. A major shift in the capabilities of the aircraft occurred in 1956 when the Scorpion was equipped with nuclear weaponry. the Air Force decided to convert 350 F-89D models into the F-89J variant. The main weapon of this updated interceptor was a pair of MB-1 Genie unguided rockets. These were later redesignated as the AIR-2A. These carried live nuclear warheads. These lethal payloads were slung under the wings, right where the drop tanks used to be. Alongside the nukes, closer to the fuselage, they retained 2 hardpoints on each wing. This allowed them to carry a total of 4 Falcon missiles. Out on the wingtips, they now mounted massive fuel tanks. These held about 600 gallons each, completely replacing the standard unguided rockets in those positions. Because of this heavy arsenal, the maximum takeoff weight of the F-89J set a record among all Scorpions. It reached a staggering 47,720 pounds. The massive program to upgrade these conventional interceptors into nuclear platforms took a couple of years. Ultimately, by February 1958, the Northrop factory in Los Angeles finished the job. They had successfully converted the entire batch of F-89Ds into the advanced F-89J variant. The first crews authorized to fly these nuclear-armed fighters were the veterans of the 84th Fighter Interceptor Squadron at Hamilton. By 1957, F-89 interceptors had become the backbone of American air defense. They operated mostly in the harsh conditions of the far north. Alongside snowy Alaska, these aircraft were based at freezing airfields in Greenland and Iceland. Since the Scorpions frequently flew over endless expanses of ice, they received a special Arctic paint scheme. The idea was simple. If an aircraft had to make a forced landing in the snow, it would be much easier for search and rescue teams to spot it. That is why the tail section, the outer halves of the wings, and the wingtip fuel tanks were painted a bright, highly visible red-orange. Back then, the U.S. Air Force routinely transferred older combat aircraft to the Air National Guard. There, these planes helped reserve pilots maintain their flight currency and keep their skills sharp. Plus, it was a great way to keep aging fighters fully combat ready. In the event of a national emergency, they could instantly be called back to active duty. The first Guard pilots to transition to the Scorpion, specifically the F-89B, were from the 176th Fighter Interceptor Squadron back in 1954. As time went on, new supersonic interceptors started entering service. These included the McDonnell F-101B Voodoo, the Convair F-102A, and the F-106A. Because of this, most of the aging Scorpions migrated over to Air National Guard squadrons. By 1962, 9 different reserve units had successfully transitioned to the F-89. This included its most heavily armed and lethal variant, the F-89J. These interceptors served the longest in the skies over Iowa and Maine. There, Guard crews kept them flying all the way until 1969. Meanwhile, they had already been phased out of active-duty Air Force squadrons by 1960. This happened as the era of supersonic aviation fully took hold. But long before the Scorpions were replaced by supersonic competitors, Northrop engineers were constantly experimenting. They were trying to turn the F-89 into a heavily armed flying fortress. For example, they fitted one F-89A with an experimental Martin MX-852 turret. Inside it, 420mm M24 cannons had a 150-degree field of fire. This gave crews incredible flexibility during an intercept. Around the same time, they tested new radars and fire control systems. They ditched older, complex setups to streamline the avionics. On 2 modified F-89C fighters, they swapped out the 6 standard guns for even more powerful 30mm Oerlikon cannons. And in 1952, they tested an airframe with a pair of T-110E3 rocket launchers. These were mounted on the sides of the nose in place of the standard cannons. They fired special 2 3/4-inch rockets, packing 25 rounds per launcher. Since the earlier J-35 engines had been plagued by reliability issues, designers continuously looked for alternative power plants. Using an F-89C as a base, they created a unique flying testbed designated the YF-89E. It was powered by experimental YJ-71A3 turbojets, pushing out about 7,000 pounds of thrust each. This test aircraft first took to the skies in the summer of 1954. They planned to use these same engines for the proposed F-89F variant. Essentially, this was going to be a completely redesigned aircraft. It would have a wider, roomier fuselage an increased wingspan, and improved aerodynamics. Midway down the wings, they integrated two large pods designed to house the main landing gear and additional fuel. The plan was to mount 3 Falcon missiles on each of these pods. Meanwhile, the nose was designed to carry 21 2 3/4-inch Mighty Mouse unguided rockets. Development of the F-89F variant began back in 1952. However, serious structural fatigue issues were discovered in the wings of production Scorpions. Because of this, the Air Force decided to scrap the ambitious project. Another proposed variant, the F-89G, never made it off the drawing board. It was designed to carry a massive arsenal. This included 54 FFAR unguided rockets, alongside a nose packed with either 6 20mm cannons or a dozen 50-caliber machine guns. The final attempt by Northrop to breathe new life into the Scorpion came in 1954 with the F-89X project. This was supposed to be a major upgrade for the aircraft, featuring new, more powerful Wright J65 Sapphire engines. With these, the interceptor could have climbed to an impressive altitude for its airframe, reaching over 57,000 feet. However, by the mid-50s, any interceptor that could not go supersonic was already considered hopelessly obsolete. As a result, the project was canceled before it could reach the flight testing phase. That brought the long development history of the F-89 family to a close. Throughout its production run, exactly 1,050 of these interceptors rolled off the assembly line across a wide range of variants. Pilots and ground crews had to deal with their fair share of maintenance and reliability issues during daily operations. Even so, the Scorpion served admirably with the Air Force. Ultimately, the aircraft cemented its place in Cold War history. It became the true backbone and symbol of American air defense in the early 50s.